Okay, so let's take a look at example number 7, the last consolidation problem in this set. And this one we would consider the time effect of consolidation because consolidation happens over time. It could be a very slow process. So yeah, feel free to pause the video for a little bit and we'll be back in a couple minutes. So, okay, so now we're back. We have a 10 feet thick clay layer, so that's the H of the clay is 10 feet. Drainage condition is really important. So this clay layer is only drained by a sand layer at the bottom. So this is very interesting. So only drain at the bottom. So this is a single-sided drain condition. And the prediction is the total settlement is 2 inches. So the ST or the total settlement is 2 inches. Technically, it should be the consolidation settlement. So, but either way, total settlement are 2 inches. The consolidation coefficient C sub V is 0.03 feet squared per day. So asking about the settlement at the end of 1 year, right? At the end of 1 year. So this considers the time effect, and first equation you need to pull out from the reference manual is to come up with the time factor. So the TV is C sub V times T over HDR squared. C sub V, we got that, and the T is 1 year. The real question is, what is HDR? So HDR is it's not H. So for now, because HDR by definition is the maximum length of the drainage. So essentially, if you have a single drain, which is the case over here. Let's say this is the clay layer, and the water can only drain from the bottom. So this is the drain side, and the drainage path would be from the top of the clay all the way to the bottom of the clay, which is 10 feet. So under single drain condition, your HDR is essentially H, the thickness of the clay. But if you have a double drain condition, sometimes you would have double drain condition. That is, you have a clay layer. You both have the sand at the top and sand at the bottom. Could it be sand? Could be highly weathered rock. And then the water can go either way. So the maximum length of the drainage would be half of your thickness of the soil. So for our case over here, it's a single drain, so your HDR is essentially H. So let's calculate the TV first. So calculate TV, we have 0.03 feet squared per day times 1 year. Make sure you're using the right unit. 365 day per year. You can use 365.25. It probably won't make a difference. And use the 10 feet squared. 10 feet squared. So basically it's 100. So TV is a parameter that does not have any unit. And then you would have 0.1095. So after you come up with the TV or the time factor of the consolidation, next one you want to do is to figure out the degree of consolidation. So this is something that you have to use the table. There is an equation, but using the table is a lot easier. So if we pull out the reference manual, we can try to find out that table. So this is the table we're talking about. So basically, we have a set of the U on the left. We have U on the left, TV on the right, and they're corresponding to each other. And if you can still remember, our TV is about 0.1095. you can find the 107. We don't really have 1095 over here, but for the purpose of FE exam, you can just choose the number that is the closest. So the U is 37%. So, but later on in your practice, you probably want to do some linear interpolation. But here, for the exam purpose, go with 37%. You should be good. So U is 37% right over here. So U is 37%. Let's go back to, so from the table, U is 37%. And if you recall, the definition of U is essentially the settlement right now, or the settlement at the end of 1 year over the total settlement. So that means your settlement right now is 37% of the final 2 inches, right? So your S is 0.74 inches. So after a year, you settled about, the soil settled about 0.74 inches. So yeah, that's it for example number 13. Oh, sorry, 17.